Alrighty, everybody. This is like take 3 for me with the video, so hopefully I get better as time goes on. What we're going to be doing today in the lesson is we will be solving quadratics by using factoring or square roots. What is a quadratic equation? Quadratic equation, for example, could look like 5x squared minus 10x equals 0. In order to solve a quadratic equation, we have various ways to do that. Remember that quadratic equations are equations of degree 2 because the highest exponent on any of the variables is a 2. And I do expect to have two answers. Whether they're two real answers or two imaginary answers remains to be seen. But we're going to try to keep it all real tonight. The first method for you solving when you come into class tomorrow is to be able to solve by factoring. And if I get a chance, I will be posting a second video refreshing you on how to factor a difference of two squares, perfect trinomial squares. But for now, I'll just try to use a variety of examples for you to see those. Solve by factoring. First of all, to solve any quadratic, the first thing that has to happen is it has to be set equal to 0, very different than the linear. Secondly, the first method that I always choose in a quadratic is to try to factor it. Break it down into a product of factors. If I can do that, and it's set equal to 0, I can apply what is called the zero product property. And in a nutshell, if you had AB equal to 0 or ABC equal to 0, what that means is that either A equals 0 or B equals 0 if the two multiplied definitely equals 0. And so the zero product property says to set each of those factors equal to 0 in order to find my solutions. And if there were 3 factors, it would carry on that I would set each of those equal to 0. So let's go ahead and do one and see if you can recall how to solve your quadratics. I'm looking at this example. We'll call it example 1. And I'm thinking, how am I going to factor that? Well, the first thing you always ask yourself is there a GCF? And there absolutely is. There's a GCF of 5x. And when I take it out, I'm left with x minus 2. I now have my factors out in front. Now, the 5 is a constant and technically a factor of its own. You can set it equal to 0 and go, that doesn't equal 0. There won't be any roots coming from there. Then you can work with the x and set it equal to 0. Well, there's one of them. The other one would come, what if x minus 2 was equal to 0? Then we would add 2 to both sides, and x equals 2. So in the end, the two solutions that I have are 0 and 2. You just solve that quadratic. We'll talk about the graphing a bit too, but they're parabolas. These are the x-intercepts because they're real solutions. They are the place where the graph would touch the x-axis. All right, let's try another example. Example number 2. Let's say you had 64x squared minus 1 equal to 0. And my direction to you is to simply solve. Well, I look at this and I say, oh, factor. Is there a GCF? No. It's a difference of two perfect squares. We're calling the factoring 8x plus 1 times a quantity 8x minus 1. Here comes the zero product property. When we set 8x plus 1 equal to 0 and 8x minus 1 equal to 0, we get two distinct roots. The first one by subtracting 1 and then dividing by 8, we get negative 1/8. And the second one by adding 1 and then dividing by 8, and we get x equals a positive 1/8. In the end, only one statement is necessary. X equals negative 1/8 and positive 1/8. Final answers. How we doing? So far, so good. I'm flying. The third one I would like to do for you is a very old and familiar one. X squared minus 4x plus 4 equals 0. This is your PTS. How do I know that? Oh, because the square root of 4 is 2. Square root of 1 is 1. And if you take 2 times 1 and then you double that, you get a 4. That means that this factors into the same two binomials, x minus 2, the quantity squared. Do I actually need to set both of them equal to 0 since they're the same? No, not really. Just one of them will do. But when you respond, you do have to recognize that 2 is what we call a double root. So we got a couple under our belt. I have one more example with the factoring. I'll do it right here over to the side. Example number 4. Example number 4 is probably the factoring that gives you the most trouble. 6x squared minus 13x minus 5 is equal to 0. There is no GCF. It's not a PTS. It's nothing special. However, it does factor. I'll be looking to break it through trial and error, looking for factors of 6, which would be either 1 and 6 or 2 and 3, and factors of 5, which would be 1 and 5. I need the factors to subtract to give me a 13, and I can see them. If I use these two, I'm going to take the 5 times the 3 and the 2 times the 1. 15 take away 2 would give me the 13. So I go ahead with my 6x squared and break it into 2x and 3x, and then my 5. Now I have to place it. I need the 5 to be multiplied by the 3, so it's going to have to go there and the 1 there. Since the middle term is a subtraction, the larger product has to be negative, and then the other positive. And now we're back to zero product property. Set each factor equal to 0 in order to find those roots. I'm going to add 5 and then divide by 2, and x will be 5 halves. I'm going to subtract 1 and then divide by 3, and negative 1/3 would be my other root. Okay, we're kicking now. When you come in tomorrow, you're going to be solving quadratics by using factoring as well as square roots. And I think that is the easier part of what's going on. Actually, one of those examples that I did could have been using square roots. So here we go. Finally, finishing off the video using, oops, too high up. Sorry, everybody. Just getting used to it. Using square roots to solve quadratics. These you love. For example, number 1, x squared equals 100. That's just common sense. 10. But negative 10 works as well. And why both? When we take the square root of both sides, we realize that doing that, we must consider both the positive and negative solution. Don't forget that. This option really is not viable when you have a middle term. If the middle term's missing, you can use the square roots. Simply separate the number with the variable that's squared, take the square root of both sides, and you have your two solutions. That one that we just did, the 64x squared minus 1, you could have added 1 to the right, 64x squared equals 1, and taken the square root of both sides, plus or minus. You would have had 8x equals plus or minus 1, and lo and behold, those are the answers that we had earlier on the other example. So use this. It makes life simple. They're not all that simple, though, so let's do one that might have a little more of a twist to it. Example 2. Let's say we have the quantity 3x minus 1 squared equals 15. Again, they are already on opposite sides, so let's go ahead and take the square root of both sides. We end up with 3x minus 1 equals the square root of 15. I need to get x alone, so I'm going to have to add 1 and then divide both sides by 3. X equals, forgot my plus or minus. Plus or minus the square root of 15 plus 1 all over 3. That's an irrational number, just a decimal, but there they both are. If you want to separate them as 15 plus 1 over 3 and negative square root of 15 plus 1 over 3, I'm okay with that. I'm happy if you leave them together as well. All right, I'm going to end it here. I hope it's good. I'll get better with time, I'm sure. You make sure you come in tomorrow with your notes. We'll see you then, and homework will be on the board, and you will be ready to rock and roll. Talk to you tomorrow.